Hello students, I am Isha. In today's video, I will be discussing the various types of dielectrics which are broadly classified into solids, liquids and gases. So let's start with types of dielectrics and see the basic classification of dielectrics. The dielectric materials are broadly classified into three categories: solids, liquids and gases. The solids you can see in the diagram are further classified into three categories. The first one is the elementary dielectrics, like you have silicon, germanium, porcelain. Then you have non-polar dielectrics which do not have permanent dipoles. Some of the examples are plastic, glass, wood, etc. And then you have the polar dielectrics. Polar dielectrics, I can give you example of Rochelle salt. It's a specific type of a piezoelectric material also, which is a very good dielectric. Then talking about the liquid dielectrics, we have mineral oil, synthetic oil and particularly miscellaneous oil category. So there are three broad categories of liquid dielectrics. And talking about the gaseous dielectrics, we have air, nitrogen, SF6, that is sulfur hexafluoride and inert gases. So this is how the broad classification of dielectrics is done. Now, dielectric materials, as I said, can be classified as solids, liquids, gases or even vacuum. Solid dielectrics are mostly used in insulating applications as they are very good insulators. They are basically used to store charges also. Talking about the liquid dielectrics, now they mainly provide insulation as well as cooling. Now they are very good at heat dissipation. So they are mainly used as cooling agents. So the purpose of using a liquid dielectric is as a coolant, you can say. And talking about the gaseous dielectrics, they can be used as insulators also and cooling agents also. So this is broadly that if you talk about solid dielectrics, what can be their main uses, what about liquid and what about gaseous dielectrics. Now let us start with solid dielectrics first. So I'll be explaining you some of the examples of solid dielectrics. I'll start with the first one, that is known as mica. Now mica is basically, you can say it's an organic material which is made up of silicate of aluminium with silicates of soda, potash and magnesium. So sodium, potassium, magnesium combined with the silicates of aluminium gives us mica, which is crystalline in nature. It is not amorphous, so it is not a compound dielectric. It is crystalline in nature. This is tough, it is hard. It has a very good dielectric strength and low dielectric loss. High dielectric strength means it can possess very strong electric field also. And low dielectric loss, the opposition to the applied electric field is not very high. So heat loss is comparatively less in case of mica. What are the uses of mica? It is used in electric irons, it is used in hot plates for insulation purpose. It is also used in armature and field coils of rotating machines so that it prevents the shock hazards. Because it's an insulator, it will prevent the shock. That is the reason mica is used in such applications. Now let's discuss the second type of solid dielectric, which is glass. Now what is glass? Glass is an inorganic material which is made up of different oxides like silicon dioxide, zinc oxide or magnesium oxide. So combination of SiO2, ZNO and MgO. It is an inorganic material. So it can be hard. It is generally hard but brittle also. It's not tough. The moment it experiences a force, it breaks. So it's hard and brittle. It has a good dielectric strength and it has a low dielectric loss. It is also highly resistant to corrosion. Glasses never corrode, right? So it is very good in case of corrosion resistance. What are the uses of glass as a dielectric? Now glass as a dielectric is used in television tubes, it is used in electric lamps, it is also used in laminated boards. Laminated boards, you can say the hoardings, they use glass which serves the purpose of insulation, which prevents shock hazards or which prevents the flow of electric charges through it. So this is these are about some applications of glass. Now let's discuss another type of solid dielectric which is known as asbestos. Asbestos is generally a type of fibrous material. It is a naturally occurring mineral material which is, as I said, fibrous in nature. It generally consists of magnesium silicate. What is the characteristic of asbestos? It has a high dielectric loss and a low dielectric strength. If I use asbestos as a coating on electric iron, it would get heated up because it has a high dielectric loss. But it has a good strength towards temperature. It can withstand high temperatures, right? So depending upon the characteristics, they can be used in different applications. Let's see what are the uses of asbestos. It is used to prevent current in the outer body of appliances, like you have electric iron box, oven, etc. It is also used in the form of tapes, cloth and boards. Now you might have seen the upper coating of an electric oven, the microwave oven, is coated with asbestos. They get heated up, but you won't feel a spark, or when you go close to it, you won't feel the charge, right? You just feel heat because of asbestos. Because asbestos has comparatively a high dielectric loss, it gets heated up. Talking about the next type of solid dielectric, we have rubber. So what is rubber? Rubber is an inorganic polymer, and it can be natural as well as synthetic. If you talk about synthetic rubber, it is prepared by the copolymerization of isoprene and isobutylene. So rubber can be naturally obtained from trees, or it can be artificially made. Let's see the characteristics of rubber. So rubber has a good thermal and electrical resistance, and it has a very good tensile strength. What do you mean by tensile strength? Stretching of rubber. It can be easily stretched, right? It won't break that easily. Now let's see what are the uses of rubber. It is used in the construction of storage housings. It is used as an insulating material for electric wires, tapes, transformers and motor windings. Let's discuss another type of dielectric material, that is ceramics. They are generally non-metallic inorganic compounds such as silicates, aluminates, oxides. Then you have carbides, borides, nitrides or hydroxides. So it's a combination of such metallic inorganic compounds. Ceramics are strong, they are hard, they are dense, they are not affected by moisture and corrosive agents, and they are very stable at high temperatures. So these are some of the properties of ceramics, and this tells us why they can be used as dielectric materials. What are the uses of ceramics? So they are used as insulators in case of plug holders. They are also used in the outer bodies of kettles, electric stoves, etc. They are also used in capacitors. The capacitors which are used in laboratories, they also are made up of ceramics because they are very good dielectrics. Now I'll move on to the next category of dielectrics, that is liquid dielectrics. So let's see what all we have in case of liquid dielectrics. The first one is known as mineral insulating oil, which are naturally available. So they are obtained from crude petroleum by a technique called distillation. So obviously they are naturally occurring. So minerals are obtained from petroleum, from crude petroleum. They have high oxidation resistance and a good thermal stability. They have a very high dielectric strength, viscosity and cooling properties, because we know that liquid dielectrics are very good as cooling agents. Now let's see what are the uses of this mineral insulating oil. It is used in cooling and insulation of transformers. You know, the major application of dielectrics, particularly the liquid dielectrics, is in case of transformers. They also maintain the insulation of the winding. So transformer which has a primary core and a secondary, primary and secondary winding, in between them insulation is required. So in that cases also mineral insulating oil is used. Examples of such insulating oils are transformer oil, cable oil and capacitor oil. These are the names given to mineral insulating oil. Moving on to the next type of liquid dielectric, we have synthetic insulating oil. Synthetic, from the name itself, can say that they are artificial oils. They are highly resistant to oxidation and fire hazards. They have a long life and safe operating conditions. What are the applications of using synthetic insulating oils? So they are used as coolants and insulators in high voltage transformers, in HVTs, right? Some of the examples are ascaryls, aerochlor, sovol, softol. These are some of the examples of synthetic insulating oils which are generally used in high voltage transformers. There they serve two purposes. They serve the purpose of a coolant also and an insulator also. The next example of liquid dielectric is miscellaneous insulating oil. They have good dielectric strength, a very high dielectric strength, high viscosity and a thermal stability up till a temperature of 200 degrees Celsius. They can withstand such high temperatures. What are the applications of miscellaneous insulating oil? They are used in high voltage transformers. They are also used in impregnation of papers. Now generally what is done, paper is also a type of dielectric material. So impregnation is a process in which air molecules trapped in the paper are completely removed and they are coated with an oil. That is what is the meaning of impregnation of papers. Some examples of miscellaneous oil: Vaseline, that is petroleum jelly, the name itself is petroleum jelly. Then you have vegetable oils, you have silicone liquids, which are comparatively highly viscous. Viscous in the sense, you can say they are comparatively denser. Viscous examples I would give: honey is viscous, castor oil is viscous, right? So these are the oils which fall in the category of highly viscous liquids. Now I will move on to gaseous dielectrics. Let's see which is the first gaseous dielectric we are going to discuss. The first one is air. Air is a naturally available dielectric material available in abundance. This has dielectric loss, I can say practically zero. Its dielectric constant linearly increases with respect to pressure. And what are the uses of air? Air is used as a dielectric in air condensers, and it is generally used in low voltage applications. Air is inflammable also, so that is the reason it is used in low voltage applications. Moving on to the next type of gaseous dielectric, we have nitrogen. Nitrogen is known as an inert gas. It's a very important dielectric material. It is chemically inert, which has very less oxidation, and it prevents oxidation and it reduces the rate of deterioration. So it is basically, you can say, oxidation resistant and deterioration resistant because of its chemically inert nature. Let's see what are the uses of nitrogen. Nitrogen is used in oil-filled transformers, and the basic function is to replace the oxidizing atmosphere, because in oil-filled transformer, if oxidation takes place, there would be rusting, there would be corrosion. So to prevent them, it is filled up with nitrogen. It is also used in cables. It is also used in capacitors under pressure, because nitrogen can tolerate high pressures also. Next, we have SF6, that is sulfur hexafluoride. It is a specific type of a gas which is actually formed, it's not naturally available. It is formed by burning of sulfur in fluorine atmosphere. So fluorine atmosphere is created and sulfur is burnt in that atmosphere. So the fumes created are nothing but SF6 or sulfur hexafluoride. Let's see the properties of SF6. They have very good cooling properties than air. It is chemically inert and it has a good chemical stability up till a temperature of 100 degrees Celsius. So it's far better than air if we are talking about cooling property. And cooling is a very important thing required in transformers. It is used in case of transformers, electrical switches, also in case of X-ray apparatus. Lastly, in case of gaseous dielectrics, we have inert gases. Inert gases are used in electronic tubes. They are used in discharge tubes as insulators. I would say inert gases are used in majorly all the applications where air cannot be used, because air is highly reactive. And if you talk about inert gases, they are chemically stable or chemically completely inert. Classification of insulating materials. Category Y, which have maximum operating temperatures till 90 degrees. Examples are cotton, silk, paper, wood. Then you have category A, which can operate till 105 degrees Celsius. The examples are cotton, silk, paper. So depending upon the type of application, these materials have been classified. What is the operating range of these materials? so we can use them in appropriate applications. We have E that has operating range of 120 degrees. Examples are polyurethane, epoxy resin, varnishes. These are all the materials which are under the class E, which can operate till 120 degrees Celsius. And we have B, which can operate till 130 degrees Celsius. Examples are mica, glass, rubber, asbestos, basically inorganic materials. Then we have class F, which can operate till a temperature of 155 degrees Celsius. They are same as class B, but comparatively they have higher stability because they can withstand temperatures till 155 degrees Celsius. Then we have class H, up till 180 degree, mica, asbestos. Asbestos, I told you, has a higher thermal stability, right? And lastly, we have class C insulating materials which can operate at temperatures greater than 180 degrees Celsius. Examples are mica, porcelain, glass, quartz, etc. So this is the classification of insulating materials. Insulating materials means dielectric materials, and depending upon their operating range, they can be used in suitable applications. So today we have discussed the different categories of dielectric materials. We have seen examples of solids, liquids and gaseous dielectrics along with the properties and their applications. We have also seen a classification of insulating materials. Hope you have understood all the topics I discussed today very well. Thank you.